is Allison Rumler, and I am a second-year master's degree student at Michigan State University in the Department of Plant, Soil, and Microbial Sciences. I currently work under Dr. Aaron Burns conducting weed science research. The project I am working on involves determining how drought conditions might impact weed density and growth, as well as determining what species will become more prevalent under drought conditions. With the current climate predictions, it is predicted that there will be an increase in precipitation, with the majority occurring during the months of May and June, with less during July and August. However, when those precipitation events do occur, they will become more erratic and intense. With that being the case, it is important that we understand what weed species will become more problematic and how might those species respond to drought conditions. So how do we study drought and weed science? We construct rainout shelters. In this image, you can see that the rainout shelters are constructed out of PVC and clear corrugated polycarbonate panels designed to intercept 70% of the total ambient rainfall and placed over 4 corn rows. Gutters were installed to eliminate water pooling at the front of the plots. On a subset of shelters, rainfall was collected. To do so, we installed a hose to the gutter that pours into the red bin, which allows us to measure how much rainfall the shelters are actually intercepting. We also installed 2 sets of rain gauges. One gauge catches total rainfall above the corn canopy, and the other one measures total rainfall that reaches the soil surface through the corn canopy. So what type of data collection do we take? To collect data on weed communities and weed densities, we install quadrats in each plot in which weed counts of each species were taken throughout the season. Once we harvest this fall, we will be able to determine weed species growth, as each species will be harvested individually, dried, and weighed for total biomass. In this image, you can see what the quadrat would look like during the growing season. This graph shows 2019 weed count results with weed density per 3 foot squared quadrat on the y-axis and weed name on the x-axis. Green bars represent plots that had full rainfall, so no shelter, and gray bars represent plots that received reduced precipitation, so with a shelter. In 2019, this location had a large variety of weed species, but these 6 were among the highest densities and can also be some of the most problematic weeds in Michigan production systems. While there is no difference in annual grass or velvet leaf densities between plots with reduced precipitation versus plots with full precipitation, there were differences in common ragweed, horseweed, and Powell amaranth. These 3 species all had higher densities under full precipitation, again meaning no shelter present. Interestingly, common lamb's quarters had higher densities under reduced precipitation. Moving on to this year's results, this graph is set up the same way as the previous one, with the only difference being that there was little to no horseweed at this location. At this location, there was a large population of annual grass, and unlike 2019, annual grass densities were actually higher under full precipitation. Velvet leaf and Powell amaranth both had similar densities under full precipitation and reduced precipitation. In regards to common lamb's quarters, just like 2019, densities were higher under reduced precipitation. Also, this year, common ragweed densities were higher under reduced precipitation compared to 2019, where they were higher under full precipitation. From these results, we can conclude that weed species will respond to drought conditions differently, and those responses may even possibly vary from year to year. It is important to remember that when weeds are drought-stressed, photosynthesis rates are lower, and this could ultimately lead to a reduction in the absorption or translocation of herbicides. If a weed cannot translocate or absorb the herbicide, then control will be minimal. In addition, applying a herbicide and receiving minimal to no control can also increase the risk of resistance to occur. Therefore, with the future climate predictions, it is important that producers understand how their herbicide programs will perform under drought conditions, as well as understanding what weed species will become more problematic under drought conditions. Understanding what weed species might become more prevalent under drought conditions can help farmers make the best weed management decisions in order to optimize control of troublesome weeds and achieve the highest yield possible. Since this is the second year of my project, we are still collecting data, but stay tuned for an update this winter as I will post the end results as well as the final corn yields. Thanks for watching. For more information, please visit our website or contact us at one of the emails listed on the screen.